because I know all the virtual students will be watching. Is this going to be on the exam? I believe there are 1 or 2 questions like this on the exam. All right, let's do a little bit of review of, where's my pen? There we go. Let's do a little review of our labeling and how we talk about things. Remember, angles are labeled with a capital letter, right? So angle A, angle B, and angle C. Sides are labeled with lowercase letters. Now we know that this is side A because it is across from angle A, and those angles and the corresponding side or the diagonal side are kind of paired together. So when we look at these formulas, we remember that an angle and the opposite side are paired, and that's how we get like capital A, lowercase a, all that good stuff. We remember that from yesterday? Sweet. And then we looked at the law of sines and how we have this long proportion, but really we only set up 2 parts of it, and we have one part that's a variable, right? We might have a side that's a variable or an angle that's a variable, and then we can do some cross multiplying to solve, right?
Yeah.
Right, okay,
Right.
Good. Now, our go-to is always going to be the law of sines because that's not too bad and most people find that easier. But if we can't do the law of sines, like in number 24, you cannot set up the law of sines, then we need to use the law of cosines. Now, the law of cosines, what it comes down to is that we take the cosine of an angle, and whatever angle we are taking the cosine of, we set everything else equal to that corresponding or that partnering side. Okay, that's the main thing you have to keep straight. All this other stuff you can kind of switch around and move around and you're going to be okay. But we need to keep straight that we are taking the cosine of some angle and that corresponding side is what we are set equal to. So this would be a good formula to have written down in your notes. Now, if we look at number 24, like I said, law of sines is kind of our go-to. If we try to set up law of sines first, we have sine of 75 over x equals sine of, and we couldn't set up the law of sines because we don't have either of these angles. We need the sine of something over maybe 5, right? So we would have 2 variables, so we couldn't do the law of sines, right? We can't solve when we have 2 variables. So that's where we would look to do the law of cosines. Now, like I said, we need to make sure that the angle is what we end with, and the corresponding side is what we are set equal to. Good? Now, with our formula, this b squared and c squared, those 2 legs, could be either 5 or 7. So if you want to put 5 squared plus 7 squared or 7 squared plus 5 squared, does not make a difference. 5 squared plus 7 squared minus 2 times 5 times 7. Questions on that setup so far? Now, the thing that's nice about the law of cosines is that you can type this entire thing in your calculator, and that will do what it's supposed to, right? You don't have to put any crazy parentheses. You don't have to format anything special. You can type 5 squared plus 7 squared minus 2 times 5 times 7 times cosine 75 in your calculator, and we can use whatever you get. So why don't you go ahead and type that in?
Where did you get to?
2 is part of the formula. 2 times b times c. Keep which one up there?
The formula.
Oh boy, yeah, I'll rewrite it right here.
Appropriate. So there was something appropriate in your calculator.
Correct. I knew who it was, I'd nail him, but 3 times c. What did you get? What did you get? What?
55.88.
55.88266668.
Now to solve for x, square root both sides. So hit second square root, second answer to take that whole 55 point whatever decimal and everything. Put it under your square root. 7.47.
Yep.
Perfect. And we can check to see if that makes sense, right? If we got that x equals 27, we probably should have an alarm going off in our head saying that doesn't really make sense. But x equaling 7.47, we can kind of see in our diagram, yeah, that's believable. Questions about that? Is that something that is like a vague memory that you've seen before, or is it just like you have absolutely never seen that, like nothing is there?
I've seen the newest is new.
Oh, yeah, you're right.
Right, you've seen every math problem.
So to help kind of, I mean, our go-to is the law of sines. If we can't do the law of sines and if we have two variables, then we'll go to the law of cosines. Kind of another trick so you can know if you need to use the law of sines or the law of cosines is that we will use the law of cosines. So we will use the law of cosines right here when we have a triangle that gives us, like in this problem, it gives us the angle and it gives us the two sides. We would call this the two sides with the inclusive angle, right? Didn't we talk about an inclusive angle?
Yeah.
Maybe.
I think so. No, maybe. I can't remember. But anyway, this is one situation where we have a side, the inclusive angle, and another side. That's one time where you have to use law of cosines. The other time where you have to use law of cosines is if you only have the sides and then you need to solve for an angle. So those are two giveaways. When we have a side inclusive angle and another side, like here, or when you have all three sides. Those are the two cases where you have to use law of cosine. So if you look at number, let's see, if you look at number 25, would you be using law of sines or law of cosines?
Law of sines.
Yeah, we could use law of sines. We know that a triangle adds up to 180. So if we do 180 minus 112 minus 15, we could find the third angle in that triangle, and then we could set up law of sines. Any questions about that law of cosines?
How would you do that one without an angle
Do which one?
on this row?
This one? So if we had it without an angle, then our variable would be in the cosine. So let's say we were solving for this right here. We would have 10 squared equals 5 squared plus 7 squared. Let's say this is A. So we would solve for the what's in the cosine. So we have to get cosine by itself, get everything to one side, and then use the inverse cosine to solve for A. Like we do with our sine, cosine, and tangent, how we use the inverses. We'd have to go through that.
Oh.
No big deal. You guys got it.
That was easy.
That was easy. We should have, isn't that a button?